Hello students, let us continue with our discussion on the linear programming problem and the method of solving it graphically. In my previous video, I had discussed with you that we had formulated the linear programming problem and we had seen the constraints of the linear programming problem. In that, we had discussed that on the graph, we plot only the linear inequalities, that is the inequations which correspond to the constraints. Now once we plot those linear inequalities and solve the solution area or find the solution area, that solution area is called as the feasible region. Since it consists of infinitely many points, so in order to decide which point will give us the optimal solution, we have the following fundamental theorems which help us to solve the LPP. Theorem 1 says that let R be the feasible region, that is a convex polygon, for a LPP, and let Z equal to AX plus BY be the objective function. When Z has an optimal value, that is maximum or minimum, where the variable x and y are subject to constraints described by linear inequalities, then this optimal value must occur at a corner point, and by corner point we mean the vertex of the feasible region. It's a very important result which tells us that amongst all the infinite points on the feasible region, the optimal value, whether it is maximum or minimum, it occurs at a corner point, which is at a vertex of the feasible region. Theorem 2 is similar and it says that let R be a feasible region for the LPP and let Z equal to AX plus BY be the objective function. If R is bounded, then the objective function Z has both maximum and minimum value on R, and each of these occur at a corner point, that is vertex of R. Okay, now and let's see one remark, that is if R is unbounded, then the maximum or minimum value of the objective function may not exist. However, if it exists, it must occur at a corner point of R. Now you all may be thinking as to, like I have used three new terms. One is the corner point, another one is bounded region, and the third one is unbounded region. A corner point of a feasible region is a point in the region which is the intersection of two boundary lines, means it's a vertex of the closed region. Okay, now a feasible region of a system of linear inequations is said to be bounded if it can be enclosed within a circle, that is if it's a closed area bounded from all sides. Else it is unbounded, that is it can extend indefinitely in any direction. Now consider the example which we were discussing, that is the example was after formulating the LPP, we had come across the LPP as maximize Z equal to 5000 x plus 3000 y, subject to the constraints 15x plus 9y is less than or equal to 540, which was the time constraint, x plus y is less than or equal to 50, which was the storage constraint, and x greater than or equal to 0, y greater than or equal to 0 is the non-negativity constraint. And here x units of type 1, y units of type 2 of cabinets are to be made, and Z is the profit function or the objective function, and 5000 rupees profit is generated on every unit of cabinet 1, and rupees 3000 is generated with every unit of cabinet 2. So the objective is to maximize the profit or maximize Z. When we plot it on the graph, we have seen it in the previous video, the shape is somewhat like this, and the it's a bounded region. OABC is the feasible region or the solution region. Now solving the two inequalities, we get this point. See, these 3 points we already know that O is the origin, which is 0 0, A is 50 comma 0, and C is 0 comma 36, whereas this B we cannot find directly, so that we will solve the two linear inequalities and get the coordinates of B as 15 comma 35. Thus let us now compute Z for each of the corner points. So we will make a table. First heading would be the heading of the first column would be corner points, then the value of Z, which is 5000x plus 3000y, and then we will see what is the optimal value, means whether if we are looking for maximum value or the minimum value. So the corner points are O, whose coordinates are 0 0, A coordinates as 50 comma 0, B having coordinates 15 35, C having coordinates 0 36. Substituting in this value of Z, we get the value of Z corresponding to each of these points as 0, 250,000 and 150,000 and 108,000. So clearly 250,000 is the maximum value, and so the maximum profit corresponds to the point or the choice 50 comma 0. So we observe that the maximum profit to the company results from the investment strategy 50 comma 0, that is buying manufacturing 50 units of first kind of cabinet and 0 unit of second kind. This method is called as the corner point method of solving LPP. So let us just quickly see the important points which comprise this method. That is, first one, the important steps which are involved in this method are: first one, find the feasible region of the LPP and determine its corner points, that is vertices, either by inspection or by solving the two equations of the lines intersecting at that point. Second point, evaluate the objective function z equal to ax plus by at each corner point. Let capital M and small m respectively denote the largest and the smallest values of these points. Next step, when the feasible region is bounded, that if it's a closed region, then capital M and small m are the maximum and minimum values of Z, and that's it, we are done. But in case the feasible region is unbounded, then we have to follow two steps. First is, capital M is the maximum value of Z if the open half plane determined by the objective function being greater than M has no point in common with the feasible region. Otherwise, Z has no maximum value. Similarly, M is the minimum value of Z if open half plane determined by the objective function less than small m has no point in common with the feasible region. Otherwise, it has no minimum value. But at the moment, we will be concentrating more on the bounded region. And keeping these points or these steps in mind, you can try out the problems of exercise 12.1. Thank you.